Let's start to create a lifecycle profile. I'm going to mouse over the section and enter the dialog to create the lifecycle profiles. There's a filter section on the top where you can specify a certain set of characteristics to query on some existing profiles. In this case, no profile with this prefix exists. I'm going to hit the plus button to create a new lifecycle profile. We have to specify a name, and within the source persistency section, you're going to select the table we explored early on. Let's specify the schema. With the auto completion, you get a nice selection option. Specify the table name. On the right side, you see a trigger type. This is the way on how you can execute your lifecycle profile later on. You have the option of manual and scheduled. Manual is just a direct execution, where scheduled provides you the option for some unattended and planned execution of the lifecycle profile. The execution of the lifecycle profile will later on transfer and displace the data between the two data stores. In the lower part section, we're providing additional information to specify the lifecycle profile. There's information available on the destination attributes, on the destination persistency, on the rule editor, and the generated objects. Within the destination attribute section, we're providing information on the storage destination, like the destination we created early on. Connected to the name of the storage destination, the certain persistency type is being displayed. By lifecycle profile, you can specify the relocation direction, like the direction the data is being transferred. You have three different options: hot to cold, cold to hotter, and bidirectional. Let's stick with hot to cold for this moment. Next option would be the package size. As we're moving large chunk of data between two stores, we're selecting and inserting records on a package size and within a package. So it's not a record by record transfer. We're selecting the data set to a package and then inserting the full package size of records to the target destination. A default value of 1 million is specified. Due to the fact that we're talking about two different data stores, a clash strategy also needs to be specified once a primary key violation would be identified. There are two clash strategies available. One is stop execution, which will roll back the full lifecycle profile execution, or the override, where the data in the target destination will be overridden. For the moment, we'll stick to stop execution. The same option can be selected for the cold to hot data movement strategy, where we also stick to stop execution. Next section would be the rule editor. Once you click on the rule editor, a dialog comes up where you can select different elements to be leveraged within the rule to move the data. Within the column section, you can specify the certain fields where we'd like to focus on cal month. I'm going to specify the filter for cal months, so it's SQL-like within the where clause. And in addition to that, we also want to select for some month only, and here we want to focus on month number 3. Once you hit the Validate Syntax button, it checks on the validation of the correct syntax. In addition to that one, it will also give you the affected records dialog. Let's move on to specify the rule within the lifecycle profile to identify the records in the source and transfer them later on to the data target destination. In the lower parts, you see the different elements of the source persistency table, where in this case, we'd like to focus on the calendar year, give it a filter. In addition to that one, we're also interested to move a smaller portion of data to the storage destination. Let's give it the option to validate the syntax. Validation went well. On the right side, you also get the information on the specified relocation direction, hot to cold, and the affected records by the given selection. You can go on and change the rule editor setting, hit again the validation syntax button, and you immediately see the amount of affected records. Let's stick to the specification we used early on. We're going to save the rule. In the upper part, you see that the data distribution overview has not been adjusted as we haven't executed the lifecycle profile. The source, the number of records, 6 unchanged, and in the storage destination, the number of records is 0. Next step would be to activate the lifecycle profile. Once the lifecycle profile gets activated, additional information will be provided. In the destination persistency, we're providing the information on the DLM generated persistence object to be used to keep the displaced data. An object is being created in the schema listed here, and the name is also listed here. As its type of dynamic tiering, this table type is classified as an external table. On the lower part, DLM also creates additional union views to provide a native HANA application the option to display and access the full data set. We have 2 union views in there. One is the pruning node view. The pruning node view will give you the option to query on the full data set, but it includes some dynamic pruning options where we're analyzing the SQL where clause, which will query the pruning node, and based on the specified options in the rule editor, we dynamically prune the access to the only relevant data store. Next to it, we're also generating a union view as a fallback strategy. The union view is being used and generated the same way you would specify a union in SQL. The union view will be always there, as for some storage destinations, we don't have the option yet to generate a pruning node view. Both views can be independent to each other, integrated into HANA applications, or being added to virtual data models, like integrated into a HANA calculation view. Within the generated object section, a relocation procedure is being created. We're extracting the information specified in the rule editor and integrate this information from the rule editor into a HANA store procedure. The relocation procedure is executed once the lifecycle profile will be put in run mode. Let's move down to the additional buttons. The Simulate button will give you the option to simulate the relocation. We have two options: the data relocation preview, which gives you the full information on your destination, the name of your data flow, the relocation direction, cold to hot, and as we only specified hot to cold, we're displaying the relevant data records from the source persistency. Next to that, we're also providing a data relocation count within simulation mode. Within this option, we do not display the content of the records. We're just displaying the number of records being displaced within the certain direction. Before we move to the run mode, we have two more options, which is the export and the import. Within the export option, we'll give you the option to export your full configuration to have a lifecycle management established also for DLM. In a later version, we're fully integrated into the HANA Application Lifecycle Manager. For this moment, we're providing an option to export and within the target system to import the full configuration of your lifecycle profile. Let's move on with the run option. Within the run option, we have two options in general, where once you selected the scheduled option trigger type, we're also offering the scheduled option to really execute the lifecycle profile. If you stick to manual, we're only providing the trigger manual option. Within the schedule relocation run dialog, you can specify on the date time you want to execute the lifecycle profile, if a certain recurrency should be specified. It will also give you the option to stop the execution and roll back the full activity on the execution of the lifecycle profile, in the sense that your time window is limited to perform the relocation runs. I do not specify anything on top, just provide the password, hit confirm, and the information pops up that the relocation run has been successfully started, and we should refer to the log screen. It takes a moment for DLM to initiate the execution of the lifecycle profile. Let's move on to check the logs of the lifecycle profile. An automatic filter will be applied and a certain ID is being specified, which is an indicator and an ID for the relocation run. Additional information like this lifecycle profile ID, the user who executes the lifecycle profile, the run status, it's completed already, the trigger type, the start time, the end time, and also the estimated data relocation count. If you click on the ID, further information is being displayed. The relocation run completed successfully. Let's go back to the lifecycle profile section. As you remember, before we executed the lifecycle profile, the initial state on the data distribution overview is being displayed. Once you execute it and the relocation run successfully completed, and you hit the lifecycle profile again, the data distribution overview got updated. Within the source, the number of records gets reduced as we moved 326,000 records to the dynamic tiering storage destination.